Welcome back to Chapter 3 of our series, SQL for Beginners, Query Any Database. In today's episode titled, Where and Filtering, Get Just What You Need, we're going to explore the powerful where clause and how it helps you sift through data to find exactly what you're looking for. So, let's dive in. Your favorite apps run millions of database queries a day, yet only a tiny slice of the data ever reaches you. In one moment, a store searches orders from last week, a bank checks transactions over a typical amount, and your streaming app narrows movies you might actually watch. Most of the time, your apps don't need all the data. They just need the right few rows right now. That's where the SQL where clause quietly runs the show. While one query hunts for today's active users, another narrows a product catalog to items in stock under $50, and a third checks only failed login attempts from the last hour. Under the hood, databases pour through huge tables but only return rows that pass your conditions. Want users from a single country? Orders in a specific status? Or posts containing a keyword? That's all where. It decides which rows are even allowed to compete for the final result. As datasets grow from thousands to billions of rows, this one clause starts to matter for more than convenience. It affects how fast your queries run, how much your cloud bill costs, and even how safely you handle sensitive data, because sometimes the most important rows are the ones you don't let through. In real projects, where becomes less about can I filter and more about how precisely can I describe what I need. You're not just checking one column, you might mix time windows, status flags, user roles, and text matches in a single condition. Think completed payments by premium users this quarter, excluding internal test accounts. Each extra detail tightens the net, shrinking results while keeping the rows that matter. As schemas grow, you learn to express business rules directly in where, turning fuzzy requirements into crisp, executable conditions your team can rely on. Think of this section as learning how to speak precisely to your data. The moment you add where, you're writing a tiny rulebook the database must follow. The fun part, that rulebook can get surprisingly rich. Start simple with one condition. SQL select star from users where country equals US. Then layer on more detail using logical operators. And all conditions must be true, or at least one condition is true, not explicitly exclude matches. SQL select star from users where country equals US and status equals active, and created at equals 2026-0101. That's already close to a real product requirement. Active US users created this year. Parentheses let you control groups of logic, just like in math. SQL select star from users where country equals US and status equals active, or status equals trial. Now you're saying US users who are either active or on trial. Miss the parentheses and you'll quietly change which rows qualify. Comparison operators widen your toolkit. Equals, not equal, equals, equals, between X and Y, in, list. Like and I like for pattern matching. SQL select star from orders where total amount between 50 and 200, and good at them you can click the Scabes a project queries version for 50 and 200. Orders where total amount between 50 and 200 and equal like them give her the worders are. SQL select star from orders where total amount between 50 and 200 and amount between like and equals between X and 200 give her the worders are. SQL select star from orders where total amount between 50 and 200 and equal like them you can click the Scabe. SQL select star from orders where total amount between 50 and 200 and equal like them you can click the Scabe. SQL select star from orders where total amount between 50 and 200 and equal like and equals about between 50 and 200 and currency in USD, Euro, and status not in, cancelled, refunded. Hear her panative any college of work through. Absolutely heavy, you can send to this very long to rejoy that even may care the two for joy. Here your automl ITVM sword, not in, undid. Here you're encoding a business slice, mid-sized, valid orders in certain currencies. Null is where many beginners trip. It doesn't behave like a normal value. It means unknown, missing. That's why SQL where last login equals null matches nothing. You must use SQL where last login is null or SQL where last login is not null. This matters for analytics, for example, users who never logged in, and for incomplete data during migrations. Text conditions can be just as expressive. SQL, select star from posts where title I like %post istros 30 days. Notice how conditions often mix time, status, and text to mirror real questions. In practice, you'll also filter on joined tables. SQL, select o.id c.name from orders O join customers. C on c.id equals O tostgress ID, where C dropdown equals enterprise, and O.paydat equals current date, 90 days. Now your rulebook spans relationships. Recently paid enterprise customer orders. You've seen how conditions shape results. Now push them into more realistic territory. Think about features you actually use. Friends online now. Deliveries arriving today. Articles saved but not yet read. That kind of behavior usually comes from several constraints working together. Consider a ride-sharing app. A query might look for trips that are not completed, started within the last 10 minutes, priced above a surge threshold, and tied to drivers with high ratings. Each extra detail narrows the focus from all trips to trips needing urgent attention in operations dashboards. In analytics, teams often encode business rules as reusable snippets. You'll see patterns like _high-value customer or is churn customer. Another word. Making yourself is for made is churn matafe, just fix into the computed event. You'll see pattern defined once, then copied into many reports. Over time, these conditions become shared language. Everyone knows what qualifies as a power user because the rule is spelled out the same way everywhere. One analogy, a hospital triage nurse quickly combines symptoms, age, vital signs, and history to decide who must be seen first. Your conditions do the same job for rows. Soon, tools will sketch conditions from a sketch of your intent. Only new signups likely to buy might expand into a precise rule tuned by past behavior. As more systems learn from your choices, they'll suggest constraints like a weather app refining a forecast. Tighten this to the last 3 days. Exclude test users. Focus on Europe. You'll shift from typing rigid rules to negotiating with an assistant that proposes, refines, and justifies each slice of data. As you keep refining conditions, you're not just asking for rows, you're shaping stories hidden in the table. Tiny tweaks can flip a result from everyone to the few who matter right now, like zooming a weather radar from global storms down to one neighborhood. The more precise your questions become, the more surprising patterns you'll start to notice. To go deeper, here are 3 next steps. 1. Open a free SQL playground like SQLBolt or dbfiddle, load one of their sample tables, for example customers or orders, and practice writing 5 different where clauses using equals, between, and in, exactly like in the episode examples. 2. Grab the SQL murder mystery game, just Google it, and solve the first part only using where filters to narrow suspects. Treat it like a real investigation and compare how each extra condition sharpens your results. 3. Download a sample dataset from Kaggle, for example, a sales or movies dataset. Import it into SQLite Browser or dbeaver, and recreate 3 filters from the episode, such as only customers from a certain region, orders after a certain date, and rows excluding a specific status, using where plus and or until your output matches your expectations. This was Owl Up, your daily step forward. This series continues with more chapters on owlup.co. Visit owlup.co to access the complete course and continue your learning journey. See you there!